Welcome to Prof 1 YT channel. Please, this video is about complex numbers, and if this is your first time watching my YouTube video, please check the subscription button and subscribe, for your subscription is a great count to my channel. So today's video is about algebra of complex numbers, and I'm very happy to learn with you guys. Yes, so please make sure you watch this video to the end because it's very good. Okay, so now we're going to talk about complex numbers. As in complex numbers, in the world we deal with two numbers, which is the real number and the complex numbers. So the complex numbers, or the conventional representation of a complex number, is normally done with it's represented by a z. So the z, as in z, represents a complex number. Now a complex number is in two parts. We have the real part and the imaginary part. So where z is the sum of real part x and I times imaginary part y. So mostly in complex numbers we have the, let's see this, it's z is equal to x plus I y. So this represents the real part of the, and this is the imaginary part. So normally the imaginary part deals with I. So let's see something here. I is used to denote the square root of -1. The real part and the imaginary part y are usually denoted by this. So mostly in as an engineer or physical scientist, we don't use I, but we use J instead of I. So I want to prove something to you. This says something here which is very vital, that the square root, so I itself is equal to square root of -1. So I is equal to the square root of -1. This is the basics of complex numbers, but sometimes with this idea they can ask you sometimes to find I exponent 20, I cube, I exponent 2, I exponent maybe 1000. How do you go about this? Now the first thing that we know that is I is equal to square root of -1. So what will be I squared? So we are going to prove I squared. Now I squared will be the square root of -1, and it will be all squared. That is all squared. So if all squared, this square is going to take part of this square. So therefore I squared, that is I squared, is going to give you -1. So from this, I squared is equal to -1. It means that we've derived I squared from I being equal to square root of -1. So now we know that I squared is -1. Now, how do you find maybe I exponent 4? They ask you to find I exponent 4. How do you go about this? You are going to simply break down this into multiples of 2. Yes, so this can be, that is I squared times I squared. That is I squared. So we know that from here I squared is -1. So we are going to get -1 times -1, which will give you 1. So therefore I squared is -1, but I exponent 4 will give you 1. This is done by breaking it down to I squared times I squared, which will give you, in indices you add the exponent if they are the same, which will give you I exponent 4. So I squared is -1. We've done that. So let's try this. Please, let's try. Pause this video and try I exponent 20. Pause this video and try I exponent 20. Okay, now I know you've tried it, so let's see, let's do it together. So I exponent 20, we are going to break down into multiple of 4. So that would be I exponent 4, all raised to the power 5. Because when we multiply 4 times 5, you're going to get 20. So now you know that I exponent 4 is 1. So you're going to get 1 or exponent 5, which will give you 1. So with this, it's very simple. What you need to know is, now let me change the color of the to green. So now you need to know the basic, that is I exponent 2 is -1 and I exponent 4 is 1. They can give you I exponent 50, you need to break it down. That is, it can be I exponent 4 times that. You can break it down, and after you substitute from the beginning, that you know that I squared is -1 and I exponent 4 is 1. So the rest, you can do the rest. Now let's move on. Now we have addition and subtraction of complex numbers. With addition and subtraction of complex numbers, we have Z1 and Z2. So normally they'll give you Z1 and Z2. What you need to do is, normally we add in algebra. If alphabet of the same kind, we add them. That is, we group like term. The same thing applies to this. You are supposed to group like term. So when a question is given, like let's see this question, that is 2 plus 3i plus 3 minus 4i. How are you going to solve this? This is very simple. You're going to group like term. So the real part to move with the real part, and the imaginary part to move with the imaginary part. So with this, you're going to get 2 plus 3i plus 3 minus 4i, which will give you 2 plus 3 will give you 5. And 3i minus 4i will give you -i. That's why we have 5 minus i. Now, pause this video and try this. So pause the video and try this. Okay, I know that you've paused, and let's see your result. So with this, we are going to do the same thing. You're going to group the real part at one place, and you're going to put the imaginary part at one place. So what are we going to do? The answer is 2. So you're going to group, that is 2 minus 3, which will give you -1 plus 7i. Note that always, when writing in a complex form, the real part must come before the imaginary part. The real part must come before the imaginary part. Sorry for my y. So let's move on. So now we have something called a modulus and argument. Mostly the modulus has its formula and the argument has its formula. So mostly we can represent this row and the imaginary part on the graph. That is, we have the row and the imaginary part on the graph. How do you do that? So the modulus of a complex number z is noted by a bar. So this represents, they are finding the modulus, and it's defined as the square root, that is the square root of x squared plus y squared. The x squared represents the real part, and the y represents the imaginary part. So they'll give a real part plus the imaginary part, which, or for you, what you want is not the I, but you want the number with the I. So hence the modulus of a complex number is the distance corresponding to the point. So as I said, it's a graph. Like when we present on a graph, you are finding the hypotenuse. So you're going to see it. So for example, and also the argument is like finding the angle of the complex number. So the formula that you need to keep is, that is this one and also this one. So now I'm going to show you something. Now as in the finding the complex number, that is for you to find the modulus, that's the distance. What you need to do is, for example, they'll give you like maybe 3 plus I. Now the I here, there's 1 here. So for you to find the modulus, you're supposed to find the square root of, that is 3 squared plus 1 squared, and that will give you square root of 10. That is it. So because this will give you 9 plus 1, which will give you the square root of 10. That is, yes, the square root of 10. So that is the modulus. But the argument, you're going to there are conditions regards to the argument. That is, we have some condition in regards to argument. Let's see that. So note the following in regards to the argument. The argument itself, it's somehow complex, but you need to know all these 4 rules in your head, because we have 4 quadrants, and with the quadrant, each quadrant has its own rule. So with the first quadrant, the angle is maintained. Now, let's do something here. This is the first quadrant. So for example, if they give you, this is the row, this is the row when you are plotting, and this is the imaginary. So the imaginary. So when they give you the value, or when they give you the complex and it falls in the first quadrant, for example, all are positive, like positive 3 plus 4i, it falls in the first quadrant, the angle is maintained. So when you find the tan inverse of the imaginary over the real, the angle is maintained. Let's check for the second. Let's take eraser to erase this. With the second quadrant, that is here, this is negative real number and a positive. So when you plot it and it falls in the second quadrant, the angle is subtracted from 180. So any angle you get when you find the tan inverse of the imaginary over the real, the answer that you get, you need to subtract it from what? 180. That will give you the argument of the complex. Yes, the argument. Yes. So let's go to the third quadrant. With the third quadrant, the angle is added to 180. So this is the third quadrant. This is negative, and this also is negative, imaginary. So when they give you maybe negative 3 plus negative 3i, you find the tan inverse of negative 3. That is, you find the tan inverse of 3 over 3. Make sure that when finding the argument, we don't use the negative. We do it positive. For example, if they give you 3 minus I, to find the argument, that will be tan inverse of 1 over 3. Ignore the negative sign and follow the procedure, follow the rules. With first quadrant, the angle is maintained. Second quadrant, you are supposed to subtract the angle from 180. The third quadrant is you are going to add the angle to 180. With the fourth quadrant also, the angle is maintained. That is it. So these are the 4 rules you need to know when finding the argument of a complex number. Yes. So thank you very much for watching my YouTube video. Please check the subscription button and subscribe for more videos. Thank you very much.